In the next item, after problem 2, we talk about this thing called the conjugate theorem. Now, do you remember what a conjugate is? Remember, a conjugate is something where you have like x plus y and x minus y. Those are conjugates of each other. So we have to first of all remember a conjugate. Now, this is a lot of reading and it's kind of confusing, so what I'm going to do is I'm going to take these two paragraphs and I'm going to make it make sense to me. And in order to make sense to me, it fits in a box or like a Venn diagram. Okay, here's what these two paragraphs say. Let's say that you have, in general, in this box, you have a polynomial. And in this polynomial, it has what we call real coefficients. In other words, it just has numbers as coefficients. Okay, it has real regular coefficients. Then there is a rule. And here is the rule for that. The rule is if you have an answer like 2 plus 5i, then you also have an answer two minus 5i. In addition to if a polynomial has real coefficients, you have kind of another category in here. And that's if the polynomial has, so tiny, sorry. This is if the polynomial has rational coefficients. If it has rational coefficients, then any type of irrational root, like if you have 2 plus the square root of 5, you should also have 2 minus the square root of 5. And that is when you have like irrational roots as answers. Now what I want to do is I want to take this idea and I want to apply it and see how you understand. Using the conjugate theorem to identify different roots. A quartic, you should know that has a degree of 4. A quartic polynomial has rational coefficients of square root of 2. Has rational coefficients. If the square root of 2 and 1 plus I are roots, what are the other two roots? Well, it has rational coefficients, so I can follow both of the items inside of here. So if the square root of 2 is an answer, I hope you understand that's the same thing as 0 plus the square root of 2, right? And we also have 1 plus I. These are the given roots. What that implies is that the other roots, would be 0 minus the square root of 2 and 1 minus I. So it has 1, 2, 3, 4 answers. The last thing I would like you to do is just make that one the negative square root of 2. Okay? So we have 4 answers. 1, 2, those ones were given, 3, and 4. We can do the got it together. If you want to attempt it and see if you did it right, go ahead and do so. Just remember, this rule only applies for imaginary and irrational type of answers. Problem 4. Using conjugates to construct a regular, it's going backwards. Given the answers, what would the polynomial be? It says, what is a third degree polynomial? Okay, so we're going to have 3 x's when we multiply them all together. If it has rational coefficients, that means we're allowed to use our rules, so that p equals 0, and we have the roots of 4 and 2i. So given to us is a negative 4 and a 2i. Now, this one is it. It's not imaginary and it's not a square root, so we do not do positive 4 because it's not an imaginary or a square root. But 2i, we will also need its conjugate, negative 2i, because it is imaginary. So we have 1, 2, 3 answers. So what we'll do is we'll write y equals just like we did in, I think it was section 5-2. We get 3 parentheses. We do x plus 4 because one of our answers was a minus 4. We do x minus 2i because one of our answers was a negative 2i. And we do x plus 2i because our third answer was a negative 2i. Alright? Now what we need to do is multiply them together. Okay, here we go. So I'm going to, you know what, I'm going to save the first one because the last two will simply be, that middle term is going to cancel out. It's going to be x squared plus 2ix minus 2ix. Now be careful with this, minus 4i squared. Alright, how much do you guys really remember from i's, imaginary numbers? Those cancel out, and this, remember, is a plus 4 because I squared, remember I squared is a negative 1? That you just had to remember way back when. So I'm going to rewrite this as y equals x plus 4 times x plus 4. Or excuse me, this one's x squared plus 4. Now I'm going to move up here and I'm going to FOIL this together. Y equals, just FOIL them, x times x squared is x cubed plus 4x plus 4x squared plus 16. And last, I'm just going to write it in standard form so it's nice and pretty. Y equals x cubed plus 4x squared plus 4x plus 16. And that is how you use the conjugate idea to help you rewrite. We'll do the next one in class. It will be a little longer because we're going to have to FOIL quite a few things together. As we move on, we're going to learn one more rule, and it is a rule by Descartes, and he talked to you about, or he came up with this theorem on how to tell how many times the graph moves and changes behavior, and that will tell you how many positive real roots it has and how many negative real roots it has, okay? Now, what does all of this mean to you? Well, let's do a problem and see how it comes to you. What you're going to do is you need to be able to count sign changes for positive x and for negative x. And I'm going to show you exactly what I mean. Take a look at the graph of this particular equation. I hope that you see it has one negative real root, right? Because it doesn't cross. See, or excuse me, it crosses once at that point. You see how it never crosses over here? That means it has no positive real roots because it never crosses on the side. But I want to teach you how you can use his rule in order to figure that out without looking at the graph. Alright, to get the positive real roots, you need to be able to take your regular equation, x cubed minus x squared plus 1, and you need to count the sign changes. One sign change, because it went from a positive to a negative. Two sign changes. Or maybe I should write, let's write first and second. All right. So what I'm going to write over here is I'm going to say that the sign changes 2 times. So here's Descartes' rule. If the sign changes 2 times, that means that it has, you ready? 2 or, now here's what his rule says. You back off 2. You back off by an even number. It has 2, I backed off by 2. I backed off by an even number. It has 2 or 0 real positive roots. Now if you look at our graph, that makes sense. We figured out that it has no real roots. All right, now the harder one, the negative one. The negative real roots. In other words, how many times does it cross the x-axis on the negative side? So what I need to do is I need to plug in a negative x. So I will have negative x quantity cubed minus negative x quantity squared plus 1. This, a negative cubed is still a negative. Now in this one, I'm going to hide this minus sign for a second. A negative squared is a positive, but since we had a minus sign, you just write minus positive x squared. Okay? So the minus sign just comes down. So let's count our sign changes. No sign changes there. Here's one sign change. So I'm going to write that the sign changes 1 time. That means that it crosses, that it has 1 negative real root. Now, if I were to back off 2, I'm going to write that on there. Can't minus 2. You can't minus 2 because it would be negative. So that means it absolutely has to have 1 negative real root. Now, if you look here, that did happen, didn't it? We had 1 negative real root that went through our x-axis. We'll do the got it together in class. If you want to give it a good start to try to count them up, go ahead and do so.